Hey kids, I'm sorry I'm not able to be there today. You should have out your PowerPoint, and this is right where we left off, changes in chromosome numbers. I will keep this short and sweet and to the point, and I can certainly go into some more details, especially about some of the disorders right at the end of this, and answer any questions on Wednesday. But I am going to talk through changes in chromosome numbers. So just like students don't always go where they're supposed to go, sometimes the chromosomes don't go where they're supposed to go. There could be mistakes. It could be meiosis 1 or meiosis 2. Simply, the homologous chromosomes do not divide up properly, whether it be an anaphase 1 or an anaphase 2. And this event is called non-disjunction, the chromosomes not separating out properly in meiosis. The result of that is that you get cells that have too many or too few chromosomes. And the result of non-disjunction is an aneuploidy. An aneuploidy, as the definition is there, is where you get cells that have the wrong number of chromosomes. We call the disorder a trisomy if there's an extra chromosome, there's 3 of a kind. For example, something like Down syndrome. That's an extra 21st chromosome. The aneuploidy would be referred to as a monosomy if you're missing a chromosome. So say, for example, Turner syndrome, which I can explain to you on Wednesday, you are missing one of the sex chromosomes. You get an X and you get nothing. So that's a monosomy. So the event is non-disjunction. The result of it is something called an aneuploidy. And it's either going to be where you have too many, a trisomy somewhere, or too few, a monosomy somewhere. If it is in the first 22 pairs of chromosomes, we call that an autosomal aneuploidy caused by non-disjunction. That is a big mouthful. Because the autosomes are the first 22 pairs of chromosomes. Most of them, they do not survive. The baby does not survive. I have except Down syndrome. There's 2 others where there is a little bit of survival, but not for super long. I'll get to that in a couple minutes. And then if it's an aneuploidy in the sex chromosomes, in the last set of chromosomes, so that's a sex chromosomal aneuploidy caused by non-disjunction. And that affects the last set of chromosomes. How is this diagnosed? If mom and dad are trying to find out if there's possibly a disorder of non-disjunction with the unborn child, they can have a procedure done called an amniocentesis. And this is where a needle is inserted and some fluid is taken out from surrounding the fetus, some amniotic fluid. They treat those cells with some chemicals. They photograph them. They enlarge the chromosomes and literally sit there and match them up. I'm sure with computers, it's done fairly quickly. Back in the day, you could actually see it. It would look like on old school X-ray film. And they would literally look to see, are all the chromosomes there? Are there too many? Are there too few? Are they missing part of a chromosome? Is there an extra part of a chromosome somewhere? And this picture is called a karyotype. And this particular karyotype is a male that does not have any disorders of non-disjunction. All the chromosomes are paired up nicely, and you can see the last set of chromosomes, the sex chromosomes. You see the X and then the Y, and you can see the Y is pretty little. I do not know who came up with this technique in saying, okay, how are we going to number these chromosomes? Well, let's take the biggest set of chromosomes and call that chromosome pair 1, and then the next biggest chromosome pair 2, et cetera, et cetera, et cetera, all the way down to pair 22. And then the last set are the sex chromosomes. If you're wondering, well, why are some of them bent over? Why are some of them straight? It's simply how they were photographed. It's kind of like why, when you have a picture taken, why sometimes your eyes are open, why sometimes you're making a silly face. why sometimes your eyes are closed. It's just how you were photographed. That's what you have here as well. This is a female that does not have any disorders of non-disjunction because, again, all 23 pairs are there. There are not too few, there are not too many, and you can see that you have 2 X chromosomes and no Y. And again, I already told you what's at the bottom of that. Going back just for a second, as mom gets older, the chances for non-disjunction go up. And it really has to do with that the spindle fibers, they age. And as the spindle fibers age, they don't pull apart the chromosomes quite as effectively as they did, when mom was in her 20s. So they talk about higher risk pregnancies for a lot of different reasons. When mom's over 40, there's a higher chance of having a child that has a disorder of non-disjunction. And I can certainly, again, talk more about this on Wednesday. This is just some other facts for you. I had mentioned that for disorders of non-disjunction that happen in the autosomes, somebody with Down syndrome can live, to some extent, a long life. Patau and Edwards syndrome, I can tell you a little bit more about on Wednesday. They're born, but their lifespan's pretty short. Some of them can live to their people that have Edwards into their 20s or 30s, but that's somewhat rare. With Patau syndrome, most babies only live a couple of weeks. I had a friend who had a child that was born with Edwards syndrome and lived about a week. It's just there's so many issues that come with a trisomy. More chromosomes, not better. Less chromosomes, definitely not better either. Non-disjunction in sex chromosomes, some people can live, pretty normal lives. I can tell you I had a friend back in Jersey who's had a daughter with Turner syndrome, and there are some characteristics of someone with Turner syndrome that I can tell you about later, but she lived a very normal life. And that is it, because we don't need to talk about pedigrees right now. So I think I'm still sharing. The karyotyping activity that you're getting a hard copy to, if you go into the Google Classroom, you will see, in theory, that's the link that you want to go to. I don't need complete sentences. I just need correct answers, and everybody turns in their own. Please turn it in on Wednesday when you see me. So you'll get to work as soon as you get the handout. You can work with your table partner, but everybody turns in their own. And that's it. I hope to see you on Wednesday.